Hello future PEs, this is Wasim Asgar. I'm a licensed professional engineer in the US and Canada. I've authored several books on the topic of FE Electrical and P Power exam preparation. I also run popular programs for preparation of FE Electrical and Computer exam and the P Power exam. In this video, I'm going to go over a couple of questions that I received from my students during a live training session for FE Electrical and Computer exam on the topic of calculus. Calculus is a broad topic within mathematics, and mathematics section number 1 is one of the big 5 topics on the exam, roughly around 10% of the exam by weightage. Within calculus, you have integration, you have differentiation, you have max-min of a function, L'Hopital's rule, and so on. In fact, math itself is not limited just to mathematics section. I tell my students that the more difficult application of mathematics actually shows up in some of the other sections, such as linear systems, communications, signal processing. The math that we encounter within section number 1, math itself, is actually relatively easy. And calculus has appearance in electronics and circuit analysis and linear systems and many other places. So it's always a good idea to brush up your mathematics and proceed throughout the rest of the exam specification and your exam preparation with confidence, knowing that you have a good handle on mathematics. If you're new to this channel, then please consider subscribing to this channel on a weekly basis. I'm posting content about FE Electrical and Computer exam preparation as well as the P Power exam preparation. And if you'd like to learn more about my FE Electrical and P Power exam prep courses, then please visit my website www.studyforfe.com. So without further ado, let's dive into the content. Mini exam, mathematics. Now this is calculus. The student didn't recommend, point out which particular problem in the mini exam it was. You guys probably know, but anyways, he provided me the screenshot. And the question was, where is the 2 coming from? Correct? Where is the 2 coming from? Now, just like trigonometry, guys, what I told you about, when I told you about trigonometry, just go through all the identities, make sure you eyeball them, make sure you do some practice problems, and that's how you're going to become a little bit more familiar. When it comes to derivatives and integrals, specifically derivatives, for example, what do we have? In the reference handbook, let me figure out what the page number is. And I'm referring to reference handbook 10.3. On page number 48, we have 27 identities. 27 derivatives. They are not really identities, but they're derivatives. Okay, formulas. All right. So your step number 1 is always to make sure that the reference handbook contains a bunch of derivatives. You don't have to reinvent the wheel. And then in 90% of the cases, the only additional thing that you have to do is to overlay, is to incorporate, is to bring to use and apply the rules associated with integration and differentiation. So when I look at formula number 26 simply tells me that the derivative of the inverse or secant inverse is of this form. Correct, guys? Right? That the derivative of secant inverse is this. So if I was actually just copy pasting this, just follow my thought process. If I simply replace u with x, what would I have ended up with? Okay, I'm disregarding x squared for a second, and I'm just staying very close to the original formula. I am going to keep it simple. Right? And I'm going to simply replace u with x. What should I end up with if I'm just simply copy pasting this? X replaces u, correct? So I should have this x squared minus 1 and d by dx of x, correct? It's like simple copy paste, no rocket science. Okay. And maybe actually, if I'm an examiner, in fact, I might have done this over here. See, I did this. I actually gave you an option that took this approach. But I got to recognize that this was a simplistic step 1, right? Now what I'm going to do is I'm going to replace the x because I didn't have x here. What did I have? X squared, correct? So I'm going to replace all of the x's with x squares. So when I go here, I replace this guy with x squared. I replace this guy which is x squared. So there's an x squared squared. right? Minus 1. And then this guy is d by dx of not x, but x squared, right? So what do I end up with? 1 divided by x squared square root x to the power of 4 minus 1 and d by dx of x squared, which is equal to 2x. Does it make sense? So there was no rocket science here. All I had to do was recognize that the bunch of formulas in the reference handbook for derivatives that I can utilize, and then work through and have a fundamental understanding of how the power rule is applied, how the product rule is applied, how the quotient rule is applied, how the chain rule is applied. Which rule did I apply over here? Or rules I applied over here? So when I'm going deeper into the function, you guys remember from the on-demand lecture explanation and my commentary in the live training, when I go deeper, when I peel the layers of onion and I go deeper and deeper into the function, that is called, which type of rule is that for differentiation, for derivatives? Which one of these 4 rules is that, guys? Chain rule. Exactly. That's the chain rule. And when you're taking the derivative d by dx of x squared, right? So the fact that I had to go into this, that's chain rule. And then when I find the derivative x of x squared with respect to x, and I call it as 2x, which rule have I applied over there? So in this step, power rule. Exactly. Right? So that's a power rule. So once you identify which derivatives you need to use, then you simply need to apply these rules and you'll be fine. Make sense? And again, between the lectures, in-lecture practice problems, quizzes, homework assignments, study guide problems, mini exams, and at the end, full and practice exam, I've made an effort to actually test you, right, or expose you to a lot of these formulas. Okay? All right. Next one. Again, this is a question from mini exam. The student is asking, hi, Wasim, can you explain why we need to multiply the same function in brackets without exponent after this? Right? So let's pick it up from here. I need to do a derivative, right? D by dt. And I think it's pretty self-explanatory, but while we're at it, we can go through it in steps. So what is the first step that I'm going to apply on this? Which of these rules? Do I need to right away go into the derivatives and figure out how I'm going to do this? What do you think? Power rule, right? And what does the power rule tell me? Where's the power rule on page number 48? Yes, 8. You're right. 8. Okay. So if I treat this guy, okay, I'm just going in a little bit depth, right, guys? Okay, just for the sake of explanation, right? As u and 3 as n, the power rule is telling me that if I'm doing a derivative and u is a function of x, right, then I'm basically going to do n, right, multiplied by u times n minus 1, correct? So if I just close my eyes, blindly follow this formula, if this is my u and this is my n, I'm going to do n, which is a 3, correct? Drop it next to this guy, and I'm going to reduce the power of my u, which is, under the brackets. I'm going to reduce this by 1. So it ends up being this. Correct? And then I still have to do a du by dx. Correct? So the original function u, I still have to take the derivative. So this is d by, in our case, it's with respect to t of the original function. Are you guys following me? Extremely straightforward, simple, straightforward. Even if you didn't know what the power rule was, you can look at number 8, and that's how I explained in the on-demand as well, right? And then you simply go about it. And that's where this is coming from. This is now the d by dx of u. So we have n times u raised to power n minus 1. So n was 3. Remember, this was 3. right? And then I have u, which was the bracket, the original function, ended up reducing its power by 1, un minus 1, and then I'm doing a derivative on u itself. Clear? When I'm going deeper into the function, that is basically chain rule, right? When I'm reducing the power by 1, that is the power rule, okay? If you like this video, then please don't forget to subscribe to this channel. Feel free to ask me any questions in the comment section of this video below. You can find tons of success stories of my FE Electrical and PE Power students over here. And if you want to learn more about preparation of FE Electrical and Computer exam and the PE Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.